Hello, and welcome back. I am Sam, your lead tutor. Today, we are going to learn the language of the network. We are tackling K62. This knowledge point covers the main network protocols in use, their purpose, features, and relationship to each other. Think of it like this: if routers and switches are the telephones, then protocols are the grammar and language we use to speak. Without agreed rules of grammar, communication is just noise. Understanding these protocols, Ethernet, IP, TCP, is what separates someone who just plugs in cables from a true network engineer who can troubleshoot complex data flows. Let's use my scaffold and ascend method. You cannot understand these protocols in isolation. They work together in a stack, like layers of a cake. At the bottom, we have layer 2, primarily Ethernet. This is about moving data between direct neighbors, like from your PC to the switch. Above that is layer 3, the Internet Protocol or IP. This is about addressing and moving data across the world, from network to network. Then layer 4, TCP. This ensures the data actually arrives intact. And helping layer 3, we have routing protocols like OSPF, which act like the GPS navigation system for the data. Let's start at the bottom with Ethernet. Think of Ethernet as your local postman. Its purpose is to deliver data within a local area network, or LAN. It doesn't know about the whole world, it only knows about the street it lives on. Its key feature is the MAC address. Every network card has one burnt in. Ethernet says, take this frame to the device with this specific MAC address. Its limitation is that it cannot leave the local network. If you want to send data to Google, Ethernet can only take it as far as your router. It's like hand delivering a letter to a neighbor. Next up is IP, the Internet Protocol. This is the global address system. Its purpose is to get data from your network to a completely different network on the other side of the planet. It uses IP addresses, which are logical, not physical. They tell the routers where in the world the destination is. Here is the relationship: the IP packet sits inside the Ethernet frame. You use Ethernet to get the packet to the router, and then IP takes over to guide it across the internet. It's like putting a stamp and a country code on a letter. Now, IP is fast, but it's not reliable. It sends packets out but doesn't check if they arrive. That is where TCP, the Transmission Control Protocol, comes in. TCP is the reliable courier. Its purpose is to guarantee delivery. It uses a famous process called the three-way handshake, SYN-ACK, to establish a connection before sending data. If a packet gets lost in the mail, TCP notices and resends it. This is why web pages load perfectly every time. It sits on top of IP. We call it the TCP IP stack because they are inseparable partners. Finally, how do routers know which way to send the IP packets? They use routing protocols like OSPF, or Open Shortest Path First. Think of OSPF as the GPS for the network. Its purpose is to find the fastest path. It is a link state protocol. This means every router shares a map of its local connections with every other router. They all build a complete map of the network. It uses sophisticated math, Dijkstra's algorithm, to calculate the shortest path. If a cable breaks, OSPF instantly sees the roadblock and recalculates a new route around it. Let's put this into practice with a common troubleshooting scenario. A user ticket says, the internet is slow. You don't just guess, you use the protocol stack. Step 1, check Ethernet. You look at the switch port statistics. Are there CRC errors? This suggests a physical cable fault. Step 2, check IP. Can you ping the gateway? If yes, layer 3 connectivity is fine. Step 3, check TCP. You use a tool like Wireshark. Do you see a lot of TCP retransmissions? This means data is getting lost and resent. In this case, you find high TCP retransmissions caused by a faulty Ethernet cable. You solved it by understanding the relationship between the protocols. For your portfolio, K62 is essential evidence. Use the STARR method to describe a configuration task. Situation: a new branch office opened and couldn't connect to the HQ database. Task: I needed to configure the network routing. Action: I demonstrated K62. I assigned IP subnets to the new LAN. I then configured OSPF on the branch router to automatically exchange routes with HQ. I verified the connection by testing a TCP port connection using Telnet. Result: the branch connected successfully, and OSPF provided redundancy. Reflection: I learned that using dynamic protocols like OSPF is far more scalable than manual static routing. If you are doing your major project, you must get specific about K62 in your technical configuration chapter. Don't just write, I connected the routers. Write, I configured OSPF with Area 0 for the backbone to ensure efficient routing updates. Right, I restricted access using an access control list that blocks specific TCP ports. This level of detail proves to the assessor that you understand the underlying mechanics of the solution you built. To conclude, remember that protocols are the vocabulary of your profession. Ethernet handles the local delivery, IP handles the global journey, TCP ensures it arrives safely, and OSPF finds the best path. They never work alone, they work together in a stack. If you master these interactions, you can troubleshoot almost any network problem. I challenge you to download a tool called Wireshark and capture some traffic from your own computer. Look at the packets, identify the Ethernet header, the IP header, and the TCP header. See the grammar in action. Thank you for your focus, and I will see you in the next session. Thank you so much for joining me today. I hope you now feel more confident in mastering this topic. If you found value in this session, I have a small favor to ask. Please hit that subscribe button, give this video a like, and follow our channel. It really means a lot to me and helps the algorithm show these lessons to other apprentices just like you who need support. Don't forget, you can download today's slides and the full transcript at www.mentorinai.com EPA Hub. While you are there, check out our mock interview and portfolio review services to make sure you are fully ready for your EPA. See you in the next video. Keep learning.